Hey guys, Alex here from Deep Cycle Power. Welcome to the Cell Doctor channel. In today's video, I'm going to explain what changes I have done so far on the software. I'm still working on getting it right and implementing all the features, but things are going, and I want to show you what new things I have implemented into the functionalities of the new software, the new firmware that's running on the MegaCell Charger. Like I said in the previous videos, we're switching to a proper state machine architecture that's going to monitor all the states that the charger is in. So we got now the basic functionality, and I'm going to show you that this got a bit more evolved than I thought it will be at the first. So we're looking now at the states on the left column. So these are all the states that the device can be. So this is a state for each cell. Each cell will have its own state machine that's going to be monitored and updated frequently. So we have the states right here, and on the top we have the events. These on enter, on loop, on exit. And the beautiful thing on this architecture is that you can have the action running when it's going into that state, an action running when it's on the loop. So right here I'm running the volt, current, and temperature action that's getting updated on loop, and you can run on exit functions that will clean up the state or stop the discharging in my case on some of the states. So this allowed me to make the code more modular and be able to add the new functionalities easier to it. So I got now the basic things, that's the charging, discharging, and checking for the low voltage, checking for chemistry, and I also updated. Okay, 1 second, I need to take this. Sorry guys, it was my kid and I wanted to see if he's all right. So as I was saying, you can switch between states and have different actions that are triggered in this case. So I got up, I also I changed the chemistry setup. So the charger will now have default chemistries that you can set. You'll be able to go into the menu and set the chemistry for the process. You can also send chemistry with the library I'm working on, and it should be implemented in the MegaCell monitor in the future as well. So I got this on, and I'm going to show you a quick run on how it's working so far. So on the left side here, you can see that I have this console. This is data from the USB. That's the serial data that the MegaCell Charger sends. It's just for debug information right now. So I'm going to unplug the cell that I have. Let me show you here how it looks. So I have this big cell right here connected with leads directly to the ports of the cell 1. So right here you can see that you have no voltage, is 0.4 volt. That's no voltage. And when I plug you can see it's changing the state. From state 0, it got into state 1, state 2, and then jumped into state 4. And if we look into this, state 0, it's not inserted. Then it got into state 1, which is new cell inserted. State 4 is, this is actually, let me do this to make it easier to talk about. All right, so it got into state 0, which is not inserted, new cell inserted. It's checking the chemistry. If the voltage is above the threshold for a low voltage cell, it will be a regular cell. If it's under the threshold, it will be called a LVC cell. It's a low voltage cell. So from the regular cell, we can run the following actions here. So you see I have event start charging. It can go into regular charge from this event right here. So these are the states that is going to transition. So right here we are in state 4, and I have this Python code that's going to send an ASC command, ACH actually. And that got the device into the charging mode. You can see that the green light is on, and we're now counting the milliamps that's going into the cell. We see that it's charging with 2 amps right here, 2104 milliamps, and the capacity is growing in this here. So this is the capacity that keeps adding. Another thing that I changed in the logic of charging is if you stop charging and then you start charging again, you will keep adding to the capacity. Before it was resetting the capacity, and I did not like that, because you might want to stop charging for some reason and change the settings or something like this, then you go charge again, and then you want to keep counting the capacity that's going into that cell. That capacity is going to reset if you are going into a discharge mode. So you are going to discharge, then the capacity that you had for charging will be reset to 0. So when you start charging, you will see actually how much power you got into the cell. All right, so this is the charging mode. I can send an event to switch to discharge mode. ADC. All right, so the orange light got lit in there. That means it's discharging, and we can see the current at 2.3 amps. And here you have the additional, and this is the capacity that had been discharged so far in this. Right, so that's the basic functionality: charging, discharging, stop charging. Let me stop it actually. A stop event will trigger the cell to go into the not inserted, then check for chemistry again to make sure that it matches, to categorize it properly, so to go into the proper state, low voltage or regular cell, and then it will allow you to continue with the process. So that's implemented. LVC charge, regular charge, cool down. This is another state that I have to implement. It's triggered when I actually have an overtemp. So you see here, when I have an overtemp event, it in regular charge or in discharge, it will switch it to the cool down state. In the cool down state, we'll have a timer to wait and keep monitoring the temperature. We might have different things that we do in the cool down, send an event to a buzzer. If we want to, we can make it buzz when a cell goes over temperature, something like this. And if it's not cooling down, if it's running away, we might have a different sound added to it. So in the new MegaCell Charger, we have a few outputs that will be available to add something to it. It's either an LED or a blinker or whatever you want, a buzzer. We can have a buzzer that sends noise on different states, on different states of the process. Charge check, yeah, I did that. A normal charge, yeah, this state, I also implemented this one. This state will be triggered when a charging stops. When you get the event for charging completed, I'm going to check at what current the charging had been finished. So if it's going to be higher than the current for termination, which is around 150 milliamps, it's going to trigger this a normal charge state. So you know that, okay, this cell got charged, but something was wrong with it. It didn't run into the full charging state, not the state. It's the charging curve that's implemented into the IC, which is constant current, then goes into the constant voltage, and the current drops until you go under 150 milliamps to finish the charging. Discharge failed. This one will trigger in case you go over temperature a few times during discharging. The reason I implemented this cool down is that some cells will overheat when you discharge them too fast, so we might have to adjust the discharging rate if a cell is getting too hot, and then categorize that cell as a lower discharge rate cell. Or yeah, we can do a lot of things to validate the cells in the future by this. So that's why I added these states, so we can use them to filter the cells and get the information from the charger to know exactly what happened with that cell during the process of testing, charging, discharging. We have the resting state, check store action. This is going to check if we need to charge or discharge a cell to reach the store voltage. Store charging, store discharging, store check. We are going to check if the store process got completed successfully and how it got store or failed store. Dispose, this is the state where we are going to discharge the cell until it reaches 0 volts basically. And with the new features of the MegaCell Charger Professional, we can actually set the discharge rate per cell. We can set it variable, so we can start with a high discharge current, then we lower that discharge current so the voltage will keep dropping low and stay low, because otherwise if we are discharging with 2 amps, for example, the cell might reach 0 volts, but when we remove the current for discharging, the voltage will drop up. So there is still some power in that cell. Not too much, a few more 100 milliamps maybe. But if we lower the current, we keep lowering the current until the voltage stays at around 0.5 or 1 volt, that cell will be depleted, fully depleted, and there's no risk of getting that cell fire or having any sparks coming from that cell, because it's dead. Right now with the current version of the MegaCell Charger, we can set the current to all the cells, so you don't have the ability to set the constant current or constant voltage per cell. You will have to modify that for all the cells, and that's not going to work because different cells will be in a different state, and there's no way to control that. You will have to have exactly the same type of cells and get them through the same type of charging, discharging, but yeah, that's not going to work, as not you are not testing twin cells. You're testing different kind of cells. Even in my test bench right here, I have a couple of color cells. So this will the color doesn't mean that they are different in chemistry, but they usually are because they come from different manufacturers. So we need to treat each cell independently and have its own settings, its own discharge and charging rate and all that. Okay, so this is the update about the states. Another thing that's going to allow me, so this is the states table. You saw that Excel file with all the states that needs to be translated into this Excel list right here, Excel list. It's an array, a table, state table array, which I formatted to match the same structure as the Excel. I actually wrote a Python code to take the information from the Excel and put it there. So if I want to add a different action, or if I update the table in some way, let me make sure I saved it. All right. I run this one. And you can see that the check chemistry got updated here. So this is a lifesaver because you otherwise had to go back and forth with this table. And that can lose a lot of time, more than clicking, and more than the time it took me to write that code to get all this and format it properly, because you see it's padding this properly. So I wrote code to write me code. That's basically what I did, and it saves time. This is the way to do it when you work on a project and you want to get it done. You find the ways that makes your life easier, so you can focus on the things that matter for that project. Right, so we can see that the state got back to state 4, which is a regular cell. 0, 1, 2, 3, 4. Yeah, this is the regular cell. It's staying there until it receives other commands. And another thing that it will allow me to do is to have these states and then write another state machine, a state machine that manages a state machine that's a high-level state machine that can run macros on these states. For example, it can monitor if it's going into the charge mode, wait until charge completed, send another event for discharging. So it will be running on autopilot, sending events to this state machine to go through the stages that are required to do the proper testing on that cell. So it will be still a few weeks. I think it will be another 2 weeks of work to get this to a level where it can be used, when it can be controlled, and I think it is going to be compatible with the MegaCell monitor. Most of the things that are not most of the all the things that MegaCell monitor can send to the old charger, it will work with the new charger as well. But then we have to update the MegaCell monitor to handle the new settings that I have added into the new charger. But that's okay, because we're still in the schedule. When we receive the hardware, I should have most of the code done. A few things, I think it will be a day or two when I receive the hardware to test everything, all the things that I have implemented for the charge and discharge, and controlling each IC independently. That will be another 1 or 2 days to get that done. After that, I can start shipping the devices to those who pre-ordered the new MegaCell Charger. Also, I want to let you know that the hardware with the metal case is going into production as well. We had a few pre-orders on those, less than we had on the plastic ones, because it's targeted more to the commercial use when you want to have a setup to plug your cells. But it's going to be more expensive because it has more connections, and it also comes with a few other features like Ethernet port. You have the variable plug-in, the variable cell holders that you can switch up or down to add different cells. Also, I received, I know it's not a big deal, but when you don't have them, it's the buttons that I will be using on the metal case. So this is going to be power button. It will be a nice LED right here, blue LED. And this is the XS12 connector. It has 6 pins and it's rated for 3 amps per pin. So I tested this with the plastic case. It fits like it has 2 millimeters between the connectors, but there's no issue on using it because you're grabbing it from top like this, and it fits like it was meant to be there. But I didn't have any idea that I will be using these external connectors when I designed that plastic case, but it works. When it works, it works. I'm glad it works, and we don't have to modify that mold because that's expensive and it takes a lot of time. So that's the update for today, guys. Again, if you did not pre-order this, you should now, because this weekend I'm going to close that pre-order from the website. I said that I'm going to close it 1 week ago, but I kept it there because I'm still working on this. We had that delay on adding a few extra features on the hardware, so that was a good opportunity for those that were a bit late or spend the money on the vacations and they didn't have the extra 200 euros to pre-order their device. But try to get it, because this is going to be a great tool to have around. The software will work like it should. You'll have all the functionalities on the button on the charger as well, so you don't have to use the software if you don't want to. You will have basically all the functionalities, and I'm going to work on the web page for the charger as well, so you will be able to send commands and see commands. That's a lot of work to get done, but I'm going to do it because I want to make this device right from all the points of view, like hardware, software, and then I will start marketing it. I'm also doing it now. I'm doing these videos because I want people to hear about this device, get them to buy it so I can continue working on it. It's a cycle that goes round, and I need to do it in order to keep this project alive. Otherwise, it will be no reason for me to keep developing this. I will stick with my other projects because I have other things that I focused on in the past years, learning about trading and all that, but that's something else. I'm not going to bring this into this channel. We're going to focus on this, and I'm going to focus on this until it's finished the right way. We got through the prototype We saw that people needs it, and now it's the time to keep working on it and make it right. Make it right from all the points of view. The previous hardware was working, it was giving good results, but now it's the upgrade time. Hardware and software as well. So again, guys, thank you very much for watching. Don't forget to subscribe to this channel. Make sure you click that subscribe button, because I need it. I need it not just for my ego that my channel is big. It's not just that. I need it so we get more people getting word about this device. Thank you very much, guys, and I wish you all the best. For those that are still on vacation, I wish you a great vacation, and when you return, you should be going back and see all the other videos that I did about this project, because I think they're good videos, and you're going to learn a bit more about the device. You don't have to know how to build this, but you should know how it works, and what to expect from it when you start using it, what you need to do. That's something that's useful to know about anything that you're using. Know a bit about how it works, how it was meant to work, and if you want to switch the way you're using it, know what boundaries you have to implement your workflow, or what can be implemented by us to make your workflow better, and make others' workflow better as well. Because if you have a good idea, then it's a good idea, and others will benefit from it as well. Have a great day, guys, and I wish you all the best.